Hello, my name is James Messina, and this presentation will be over supercapacitors. This picture that you see here is the structure of a supercapacitor, and then also the circuit diagram. Now, this presentation will be going over the relation of supercapacitors and the electromagnetics. So, the overview of supercapacitors. It's also referenced as an ultracapacitor. Some characterizations has a high capacitance value and low voltage limits. Functions are utilizing porous materials as separators to store electrical charge, which is different compared to regular capacitors. And then also is used for rapid charge and discharge cycles. Some benefits include requires less circuitry, does not require special charging and discharging control circuits, and also has a high power density. Now, further in this presentation, we'll go over some more benefits, but for now we won't. Then also on the right, we have a picture of different types of supercapacitors. So first being the double layer capacitor, the second being pseudocapacitors, and the third being the combination of both, which is hybrid capacitors. All right, next is the supercapacitor's relation to electromagnetics. First, going into electrostatics, the comparison to capacitors. Well, both supercapacitors and regular capacitors use static electricity to store energy. However, supercapacitors have a much larger area with smaller distance between the plates. Also is dielectric implications. The field polarizes so that the plates can store more charge at a given voltage. Now, if you look over to the left, we have two pictures. The top being the actual regular capacitor and the bottom being a supercapacitor. As you can see, there is a difference between the two. Going into Faraday's law, carbon-based supercapacitors have an excellent power output and superior cycle life. Also, the magnetic field generation is caused by the difference in electric potential between the positive and negative electrodes during the charging and discharging process. Now we're going to get into some real-world applications using supercapacitors. The first application being a storage device for voltage stability. This is used in renewable and hybrid energy systems, which regulates the source and the grid. If you look over to the right, we have some examples of that. Examples being the cordless screwdriver, the street lights, the wind turbine, and the train lines. Now into the second application with reducing energy consumption and carbon dioxide emissions, which rapidly stores and delivers energy. So if we look over to the right, we have some other examples. We have the railroad locomotive. We have the cranes and the forklift. We also have the aerial lift and the electric vehicles and hybrid electric bus. Finally, we're going to go over the summary of supercapacitors. As you can see in the picture, it describes advantages and some drawbacks. We talked about supercapacitors have a high power density value, a quick charge and discharge, and a long shelf life and extended lifetime. In application, supercapacitors do not blow up in a short connection, they stop energy flow when fully charged, there's no gas emissions, and is environmentally safe. However, these are some drawbacks that we did not discuss. Supercapacitors need a balancing circuit for series connections, price and market delivery challenges, power supplies for a very short duration, and has the highest dielectric absorption. These are some references that were used for this PowerPoint presentation. Thank you for listening.